Hello student, today I am going to discuss the continuation topic of a mole concept. Last class we discussed the mole concept, especially how to find out the number of moles in terms of a number. But today, this class we will cover how to calculate the number of moles in terms of a mass as well as in terms of a volume. So, this mole concept is very important. Why? Because it can be connected to the other concept very easily, as well as it will require entire part of chemistry. As far as JEE and NEET is concerned, as well as board exam is concerned, as well as advanced exam is concerned, the paper setters generally not able to make a questions without putting a mole concept into the papers. So that's why mole concept are very important. Okay, let us start the topic today. How to calculate the number of moles in terms of a mass. To understand that one, first we need to know how to find out the molar mass and what molar mass it is. In detail, we need to know that one. Let us start with the discussions of molar mass. Molar mass. In short form, we will write down mm. So, what is molar mass? Mass of a 1 mole of substance. Mass of a 1 mole of substance. As simple as. So, molar mass क्या होता है? Molar mass होता है mass of 1 mole substance. That means 1 मोल जो सब्सटेंस होता है उसका जो मास होता है वही मोलर मास है. और the mass of a 1 mole of substance is nothing but a molar mass. The substance can exist in different form. What are that? Atomic form, molecular form, ionic form. Mainly substance, whatever questions will come in the 3 form. So that's why substance can exist in which form? Atomic form. Whenever substance exists in atomic form, we will call it as a gram atomic mass. Gram atomic mass. Whenever substance is in molecular form, whenever substance is in molecular form, we will call it as a gram molecular mass. Whenever substance is there is ionic form, whenever substance there is in ionic form, we will call it as a gram ionic mass. So that very simple idea, mass of a 1 mole of substance is nothing but a molar mass. Yes or no? So substance can present in 3 different form. What are that? Atomic form, molecular form, or ionic form. If it is there in atomic form, we used to call it as a gram atomic mass. If the substance is in molecular form, we used to call it as a gram molecular mass. If the substance is in there in ionic form, we used to call it as a gram ionic mass. Let us go into the one by one. So, if the substance is there in a atomic form, then we used to call it as a gram atomic mass. Now, if I say 1 gram atom, remember this concept. 1 gram atom equals to mass of 1 mole of atom in grams. If I say 1.5 gram atom, what is the meaning? Mass of 1.5 mole of atom in grams. If I say 3 gram atom, what is the meaning of that one? Mass of mass of 3.5 mole of atom in grams. The same way, if I say 1 gram molecule, if I say 1 gram molecule, mass of 1 mole of molecule, 1 mole of molecule, 1 mole of molecules in grams. If I say 1.5 gram molecules, 1.5 gram molecules, which is nothing but a mass of 1.5 mole of molecules in grams. So that means, same way, if I write down 1 gram ion, mass of a 1 mole of ion in grams. If I say 1.5 gram ion, mass of a 1.5 mole of ion in grams. The main point is, before the gram atom, before the gram molecule, before the gram ion, whatever number is there, that number represents the number of moles. Like, if this number is there, you look at 1, 1.5, 3, whatever, these number represent number of moles. Before the gram ion, before the gram molecule, before the gram atom, whatever number is there, that represent nothing but what? Number of moles. Same way, this number represent what? Number of moles. Yes or no? So, ग्राम आयन के पहले, ग्राम एटम के पहले और ग्राम मॉलिक्यूल के पहले जो नंबर रहता है वो नंबर ऑफ मोल्स को रिप्रेजेंट करता है. एज सिंपल एज दैट. सो बिफोर द ग्राम आयन, बिफोर द ग्राम मॉलिक्यूल, बिफोर द ग्राम एटम, whatever number is there, that represent the number of moles. So now first we introduced molar mass concept. What is molar mass? Mass of a 1 mole of substance. As simple as that. And substance can exist in 3 different forms: atomic form, molecular form, and ionic form. If it is exist in atomic form, we used to call it as a gram atomic mass. If it is exist in molecular form, we used to call it as a gram molecular mass. If it is exist in ionic form, we used to call it as a gram ionic mass. I hope is it clear to everyone. Next, we will going to discuss how to find out the 1 mole of atom mass and AMU, how the relation is it. Let us look at, if you look at, for that we are going to discuss first how to find out the mass of 1 mole of atom, mass of 1 mole of molecule, or mass of 1 mole of ion. For that purpose, generally, mass of atom, mass of molecule, or mass of ion, generally we used to express in terms of AMU, atomic mass unit. First, let us look at what is AMU. 1 AMU. A for atomic, M for mass, and U for unit, atomic mass unit. So 1 mu will be equals to 1 by 12 into mass of 1 C12 isotopes carbon atoms. I hope you know 10th standard what is isotope, isotone, isodiapher. If not, also in atomic structure we will explain. You need not to worry for that. You just look into our channel where every concept will be discussed, every type of problem will be discussed, and always in this channel you will get triple C. What is triple C? C for clarity, C for certainty, C for confidence. These 3 always you will get over here. Though we have in our chemistry Heisenberg uncertainty principle, but in our channel, by our expertise, you will get certainty about the subject. So now look at 1 AMU. 1 AMU is nothing but a 1 by 12 into mass of 1 C12 isotope carbon atoms. And scientists got this value by calculations. Mass of 1 C12 isotope atom is in gram is 1.999 into 10 power of minus 23 grams. So these things will come 1 by 12 into 1.99 into 10 power of minus 23 gram. Now if I calculate these things, finally this used to come 1.66 into 10 power of minus 24 gram, or which is nothing but a 1.66 into 10 power of minus 27 kg. Because gram to kg means divided by 1000. That's why. Yes or no? Very simple. So now 1 mu equals to, we got this value. Again scientists observed 1 by Na. Na is a Avogadro number. 1 by Na means 1 by 6.023 into 10 power of 23. Last class we discussed. This value also is nothing but a 1.66 into 10 power of minus 24. This is also gives rise to same value. Yes or no? So that means what I can say, 1 mu equals to 1 by Na gram. Yes or no? Because 1 mu value also 1.66 into 10 power of minus 24 gram in gram unit. Again 1 by Na also giving same value 1.66 into 10 power of minus 24. So that's why I can say 1 mu is nothing but a, 1 by Na gram. That only I did over here. Now nowadays this 1 mu they used to say same thing. 1 mu is nothing but a 1 unified mass. 1 unified mass equals to 1 aston. 1 aston equals to 1 avogram. 1 avogram equals to 1 Dalton. So that means in exam whatever form they are giving, either in form they are giving AMU, either they are giving unified mass means U, either they are giving in aston, either they are giving in 1 avogram, or either they are giving you 1 Dalton. Everything express the same thing. That means 1 mu equals to 1.66 into 10 power of minus 24 gram. Same way 1 unified mass equals to 1.66 into 10 power of minus 24 gram. Same way 1 aston equals to 1.66 into 10 power of minus 24 gram. Same way 1 avogram equals to 1.66 into 10 power of minus 24 gram. Same way 1 Dalton equals to 1.66 into 10 power of 24 gram. Is it clear? So now why I take this first 1 mu? Because whatever the mass of atom we will discuss, that is nothing but a relative atomic mass. There are two type of, later on we will go for that discussions also. There are two type of mass of atom is available. One is relative atomic mass and one is average atomic mass based on the percentage abundance of different types of isotopes of that element of atom. So now first we will go for relative atomic mass. Whatever reported in periodic table we used to observe, oxygen atom mass is 16 AMU, carbon atom mass is 12 AMU, all those are nothing but a relative atomic mass. Then we need to know what is relative atomic mass. Relative atomic mass. What is relative atomic mass? Relative atomic mass is nothing but a mass of one atom of one element. Mass of one atom or one element with respect to 1 mu. That is nothing but a relative atomic mass. What is relative atomic mass? Relative atomic mass is nothing but a mass of one atom of one element with respect to 1 mu. Because relative means in comparison with something. So relative क्या होता है? किसी के रेस्पेक्ट से किसी और चीज कितना बड़ा है और कितना छोटा है. So that's why relative atomic mass is nothing but a mass of one atom of one element with respect to 1 mu. Like mass of one oxygen atom, 16 mu. That means oxygen one atom is 16 times heavier than 1 mu. Like nitrogen one atom, 14 mu. That means mass of one nitrogen atom is 14 times heavier than 1 mu. The idea is like this. What value is there, that times it's heavier than with respect to 1 mu. So that's why from periodic table, that basic things we need to remember. That means mass of every element of atom. General idea, what is the atomic number, but it is not true in all cases, but generally maximum cases we observe what will be the atomic number, that if you make it double, almost you will reach the mass number. That means mass of that element of atom in AMU. Like oxygen atomic number is 18. So then oxygen one atom mass will be how much? 16 AMU. But it is not true for all cases. That also true. If you look at sodium, not exactly. Like sodium atomic number is 11. If I make a double, it is 22. But sodium, one sodium atom mass is 23 AMU. So like that, it is not exactly, but most of the cases it used to match. Whatever atomic number, if you make it double, you will get the mass of one atom in AMU. So now we understood this concept AMU and relative atomic mass, which will help to calculate the molar mass. Let us look at the molar mass calculations for atom as well as for molecule as well as for ion. So now if you look at, I am going to discuss that one. Suppose I want to discuss that mass of 1 mole of oxygen atom, that I want to find out. Basic all those things you have to remember from the periodic table, that value, the mass of every element of atom, like sodium 23, like chlorine 35.5, and like phosphorus 31, like sulfur 32, like silver 108. So like that you have to remember all those data. Okay na? So now mass of 1 mole of oxygen atom we are going to calculate. So then mass of one oxygen atom, mass of one oxygen atom, that value I told, just you have to remember, is 16 AMU. That means one oxygen atom 16 times heavier than 1 AMU. So then mass of one oxygen atom is 16 AMU. So now I need to find out mass of 1 mole of oxygen atom. We know 1 mole of oxygen atom means how many? I told 1 mole of anything means Avogadro number of that substance. Last class we discussed that things. So that's why. So mass of 1 mole of oxygen atom, 1 mole of oxygen atom will be equals to 16 into Avogadro number, that much AMU. Because one oxygen atom mass is 16 AMU, Avogadro number means Na. So then Na oxygen atom mass is how much? 16 into Na. Like simple logic, there is 1 apple price is 10 rupees, 10 apple price is 10 into 10, 100 rupees. Same logic, one oxygen atom mass is 16 AMU, Na number of oxygen atom, because 1 mole means Na number of atom is there. So then 1 mole oxygen atom mass is nothing but how much? 16 into Na AMU. Now I want to convert this AMU to grams. So now just conversion factor we discussed, 1 AMU is nothing but a 1 by Na gram. Just now we discussed AMU to gram conversion. I hope you remember. So now this many AMU is there, I need to convert in gram. So that's why what I want to do, 16 into Na into 1 by Na. Now I will not write AMU, now it is in gram. Yes or no? Because conversion factor is what? 1 AMU 2 grams, 1 by Na grams. Whatever AMU is there, if you multiply it by 1 by Na, then that is representing the grams. So that's why this much AMU was there, multiplied by 1 by Na, now it is in grams. Then Na cancel out, you are getting how much? 16 gram. That means mass of one oxygen atom, and the mass of 1 mole of oxygen atom, that number wise they are same but meaning wise heaven and hell and different. Mass of one oxygen atom in AMU in 16 AMU, mass of 1 mole of oxygen atom in gram 16 gram. Understood? Due to conversion factor, Avogadro number cancel out. That's why their value are coming same, but one is in AMU, other is in gram. So 1 year examiner asked the questions like this: mass of one oxygen atom. Options they are giving: first option 16 gram, second option 16 into Na AMU, 16 into Na AMU, and third options they are giving 16 by Na grams, as well as if I give you fourth option 16 AMU. Now you look at the question what I asked. Mass of one oxygen atom I asked. First options they are giving 16 gram. So 16 gram is a molar mass. Molar mass means what? Mass of a 1 mole of substance. Here substance is there in which form? Atomic form. So that's why 1 mole of oxygen atom mass is nothing but a 16 gram. What is what? This is the mass of a 1 mole of substance. Then 16 gram is nothing but what? Molar mass of oxygen atom. Some book they will say it's a atomic weight. Understood? So that's why mass of a one oxygen atom is how much? Because this is a 16. You can do it. There are two ways. What is that way? 1 mole of oxygen atom mass is 16 gram. That means Avogadro number of number of oxygen atom mass 16 gram. Then one oxygen atom mass will be how much? 16 by Na gram. Simple eliminatory method you can do. That's what I did. Then your answer will be 16 by Na gram. Option is there? Yes, third option is there. Another way you can do, the mass of one oxygen atom in AMU, how much? 16 AMU. That option also is there, fourth options. So that's why third and fourth option is the correct answer. If they are giving generally advanced question, they used to ask multi-correct. So then that time third and fourth options will be your answers. Is it clear? In until and unless they are not mentioning which you need, then third and fourth options is answer. If they are asking mass of one oxygen atom in gram, then only answer will be third options. Point is clear. If they are asking mass of one oxygen atom in AMU, then your answer only will be fourth options. Is it clear or not? Understood? So now we discussed how to get the molar mass and in the atomic form, and that point we discussed previous slide itself, that the before the gram atom, before the gram molecule, before the gram ion, whatever number is there, that represent the number of moles. Then let us take one example for molecule and one example for ion, and then we will go to the problem. Point is clear? Huh? So now let us look at now for the molecules. If I say calculate mass of 1 mole of H2SO4, then how we can calculate? Whenever you have you are going to mass of 1 mole of H2SO4, you are going to calculate. First let us look at mass of one H2SO4 molecule in AMU, because molecular mass or one atomic mass always they will express in terms of a AMU. One ion mass they will express in terms of what? AMU. But molar mass generally expressed in terms of what? Grams. So now if you look at, whenever we want to find out the mass of one molecule of H2SO4, I have to sum up the mass of one element of atom, all element of atom multiplied by their number, which number they are present into that molecule. That's why mass of one H2SO4 molecules will be equals to 2 hydrogen atom is there. That's why each hydrogen atom mass is 1. So that's why 1 into 2 plus one sulfur atom, which is 32, From where you will get value? From periodic table, just now I mentioned. Plus each oxygen atom is 16, 16 into 4. So overall value used to come 98. As it is a 1 H2SO4 molecule, it should be AMU. Because one molecule always in AMU. 1 mole of molecule we express in terms of what? Gram. That is nothing but a molar mass. Now, mass of 1 mole of H2SO4, 1 mole of H2SO4 will be equals to how much? Because 1 H2SO4 molecule mass is 98. Then 1 mole means Avogadro number. So that's why 98 into Na. Na means Avogadro number. This much AMU. Now I want to convert AMU to gram. What I have to do? Multiplied by 1 by Na. Because conversion factor AMU to gram is how much? 1 AMU equals to 1 by Na gram. That's what I am doing over here. 98 into Avogadro number into 1 by Na. Now it is not in AMU, it is in grams. It is in grams. Now Avogadro number cancel out. Then we are getting 98 gram. This 98 gram is nothing but what? Molar mass. So that means mass of 1 mole of H2SO4 in gram, how much? 98 gram. Point is clear. So then same in case of a molecule's atom, same thing is coming. The mass of one molecule and mass of a 1 mole of molecule, their value, the value number are same, but magnitude, their unit are different. And concept wise, heaven hell and difference. So now, if you want to find out the mass of one H2SO4 molecule in grams, then same way, mass of one H2SO4 molecule in gram I need to find out. Then 1 H2SO4 molecule in AMU, how much? 98 AMU. Then AMU I need to convert in gram, multiplied by 1 by Na. You did it. That means whatever mass is there in AMU multiplied by 1 by Na, that will give rise to in gram. So then mass of 1 H2SO4 molecule 98 AMU multiplied by 1 by Na, directly AMU is converting to what? Grams. Now this is will be grams. Is it clear? So then molecule also we did it the same way we did for the atoms. Now for the ions also you check it out. Briefly we discuss. Suppose I have a CO3 2 minus. Generally in case of an ion, one formula unit we used to take as a molar mass, ion or ionic compound. In formula, whatever atom in their number is there, that formula amount of mass is nothing but a molar mass. Is it clear? So now CO3 2 minus what represent? 2 electron is extra. If it is plus, that many electron are deficient. If it is a minus, that many electron are extra. Anyhow, electron is not contributing the mass of the overall substance, because mass of atom, molecules or the ion, so always is contributed by the particular element of atom, how many neutron and proton present, that is contributing the overall mass of that element of atom. So now here CO3 2 minus is there. Then here if I am going to calculate, then mass of one ion will be equals to carbon is 12 plus 3 oxygen, 3 into 16, 48 plus 12, which is nothing but a 16 AMU. So then here you look at mass of one ion is 16 AMU. Then mass of 1 mole of ion, mass of 1 mole of ion, 1 mole of ion will be equals to 16 into Avogadro number, AMU, because you know very well. So then 1 ion 16 AMU, Avogadro number of ion will be 16 into Avogadro number, Na is Avogadro number. So now if I convert AMU to gram, then I need to multiply it by 1 by Na. That's what I am doing over here. Now when I multiplied by 1 by Na, now it is not gram, it is not AMU, it is in gram. Na cancel out, then we are getting what? 16 gram. So that's why molar mass of this ion is nothing but how much? 16 gram. Is it clear? So we discussed molar mass in case of atom, in case of molecule, in case of ions we discussed. Now let us discuss one problem based on this, then we will go to the how to find out the number of moles in terms of a volume. Okay na? So let us look at to the problems. Next, the problem is giving 28 gram of N-3 ion present. And always remember, in case of an formula only, whatever atom is there, that atom mass, if you summed up, that is nothing but a molar mass of that ion in grams, as simple as that. And if the element of atom is there, the molar mass means the atomic weight. That means what is the mass of that atom in AMU, that value, if you put with write down with unit gram, then that is a molar mass. And for one molecules, may then whatever the element of atom is there with their number, if you summed up all element of atom mass, then write down by gram, that is nothing but a molar mass. Is it clear? So now you look at problem is giving 28 gram of N-3 ion is present, and first question they are asking number of moles of ion present. Because best way to understood this is how to calculate these things. Let us take a problem, and if you go into the depth, then you will never forget that concept. So now 28 gram of N-3 ion present, number of moles of ion present in it. First point asking. Second they are asking total number of electron in it. Third questions, total number of proton in it. Fourth questions, total charge in it. These were the questions they asked over here. Now, as of now, just I mentioned how to calculate the molar mass. Now I will give you that formula. Whenever they will give the mass, how to find out the number of moles. Then number of moles in terms of a mass. This is small n means number of moles. Number of moles in terms of a mass given weight into the problem. Given weight or mass, that should be also in gram, divided by molar mass of substance. Substance may be ion, molecules or atom. That should also will be in gram. That is nothing but a number of moles in terms of a mass we can find out. Then immediately what we will get? If you look at here, 28 gram of N-3 is there, then given weight will be equals to 28. Then molar mass of substance, here ion is there. In formula unit, what are the thing is there? Only one nitrogen atom. That means 14 Mu, one nitrogen atom. Then 1 mole of means, molar mass means 1 mole of substance. Then it should be in 14 gram. So that's why 28 divided by 14. This also is there in gram. These also there in gram. Gram cancel out. Then you are getting how much? 2 mole. So then number of moles of ion present is how much? 2 mole. So now 2 mole of ion is there. Then total number of ion will be equals to 2 into Avogadro number, because 1 mole of ion means Avogadro number of ion. Then 2 mole means 2 into Na Avogadro numbers. This many total number of ion. Now they are asking number of moles of ion present. We got the first answer 2 mole, and then total number of ion in this 2 mole, 2 into Avogadro number, because in 1 mole how many is there? Avogadro number of substance. It may be ion, it may be atom, it may be molecule, whatever it is. But in here 2 mole ion is there, that's why total number of ion 2 into Avogadro numbers. Now they are asking total number of electrons. Now look at total number of ion is there how many? 2 into Na. Then you look at in one ion, how many electron is there? Nitrogen atomic number you need to remember. Nitrogen atomic number is 7. So that means in a neutral element of atom, atomic number represent that many number of electron and that many number of proton should be present. That's why every element of atom in elemental form, they are neutral. So that's why that in nitrogen, if I write down, that means nitrogen, if I write down, this is atomic number, this is your mass number, atomic number. That means in neutral element of atom, there is a 7 electron and there will be a 7 proton. But here it is not like that. Here is situation is n-3. That means there is a 7 proton and then there will be a 10 electron. 3 electron is extra. Proton never can be extra. Only charge is developed any atoms or any species due to excess of electron or deficiency of electron. If deficiency is there, plus charge. If excess electron is there, minus charge. Proton cannot be extra or proton cannot be deficient. Only in terms of electron is extra or electron is deficient, and then only plus minus used to appear into that species. So now n-3 means there is just 7 proton and 10 electron in one ion. But we have total number of how many ion? 2Na number of ion is there. That's why total number of electron will be equals to 2Na into 10. Because one ion there is a 10 electron, then total ion is there 2Na, then total number of electron will be how much? 2Na into 10, 20Na. Same way, total number of proton, you look at, electron is extra, proton is not extra. In one ion there is a 7 proton. We have total number of ion how much? This 2Na. Then total proton will be 2Na into 7. So that's why total proton will be 2Na into 7. Then total charge in it, same idea. Total charge you look at. Total charge in one ion there is a -3 unit charge is there. Then total ion is there how much? 2Na. Then that's why total charge will be 2Na into -3. Yes or no? So this is your fourth question answer. This is your third question answer. This is your second question answer. And first question answer we got it 2 mole. Now this is the concept wise we discussed every point. Now I am giving you one mantra. If you forget everything, if you follow blindly that mantra, whenever they will ask total number of atom, total number of electron, total number of neutron, total charge, then always what we have to do? Number of moles into Avogadro number means Na into one of the substance, how many is there. So that's why whenever they will ask, mantra is what? This is mantra. Mantra is what? Whenever they will ask total number of atom, total number of electron, total number of proton, so then number of moles into Avogadro number into one of the substance, how much present, that's what everywhere we did. You look at, so suppose you look at total number of electron, number of moles of this ion we calculate how much? 2 into Avogadro number Na into 10, in one of the substance 10 is there. That's why I generalize that things by mantra. If they are asking total number of electron, total number of proton, total number of charge, number of moles into Avogadro number into one of the substance, you look at for proton, number of moles 2 into Na Avogadro number into one of the substance 7. So now same way, total charge, number of moles into Avogadro number Na into one of the substance -3. So that's why I am giving you mantra. If you forget about all concept, whenever they are asking total number of electron, total number of proton, total charge, always you apply number of moles into Avogadro number into one of the substance, how many is present. Is it clear to everyone? Okay. So now go to the next concept, which is nothing but a by volume, how to find out the number of moles. So number of moles in terms of a, this is a number of moles, this is nothing but your number of moles, small n, number of moles equals to given volume means in problem, especially for the gases, these things will be applicable. Given volume in liter by 22.4 liter, or given volume in ml, given volume in ml divided by 22,400 ml. That way we can do it, because it is observed experimentally at STP or NTP, standard temperature pressure, normal temperature pressure. Difference is, both cases temperature is 273 Kelvin, but STP pressure is 1 bar and NTP pressure is 1 atmosphere. Bar and atmosphere slight difference is there. So then in terms of a 1 atmosphere equals to 1.023 bar. So then there is a slight difference is there. But in STP actual volume is 22.7 liter, but in NTP 22.4 liter. But in common we used to take at STP or NTP 1 mole of gas occupy volume 22.4 liters in liter unit, or in ml 22,400 ml. So that's why whatever volume they are giving in liter divided by 22.4 liter will give rise to number of moles of that things. Suppose if I take in terms of a one problem, then I will summarize the thing in the form of a Y map, and then we will bind up the things. Now if you look at, if they are giving 11.2 liter methane gas present, and then they are asking questions, how much total atom present in it. Then how to calculate these things? That means whenever they are asking total number of atom, just now I explained total number of atom, total number of electron, total number of proton. I told what you have to do. You have to do like that first you have to calculate the number of moles, and then number of moles into Avogadro number into one of the substance. That means in one of the methane molecule how many atom is there. With that you have to multiply, or you can say atomicity. Atomicity means the number of atom present in one of the species. It may be ion, it may be molecule. Okay, so then that whenever they are asking total atom in it, what you have to do the operations? Number of moles into Avogadro number into atomicity. Atomicity means number of atom present into the one of the species. It may be molecular, it may be ion, whatever it is. Is it clear? So now first, for the calculation of number of mole, they are giving the volume of methane gas in liter, and within bracket they are mentioning at STP. Then immediately I will calculate. Just now I explained how to calculate the number of moles in terms of a volume. Then immediately number of moles will be equals to given volume by 22.4 liters. So then given volume means should be in liter. Both unit will be same. Then only unit cancel out. Then only you will get a certain values. So then immediately volume is given in liter how much? 11.2. And then these things is nothing but how much? 22.4. Then we are getting nothing but a 1 by 2 mole, half mole. Then methane means you know very well. Everybody knows CH4 is a methane. In one molecule there are 5 atoms, there are 4 hydrogen atom and 1 carbon atom. So that's why if I got, first we got the number of moles by our formula, given volume of the gases at STP divided by 22.4 liter if the volume is provided in liters. We got the half mole. So then once we got the number of moles, they are asking total number of atom. Then I told that idea, total atom will be equals to number of moles, which is half, into Avogadro number, which is Na, into one of the substance how many is present? 5. This will be your answer. Half into Na into 5. Na value always you know. I hope Avogadro number value 6 point, tell me, 023 into 10 power of 23. Yes or no? So then total atom we got it very easily. Yes or no? That only they asked over here. So now I am summarizing these things. The number of moles calculated in terms of a mass, in terms of a number, as well as in terms of a volume. Let us look at that one. So then we discussed the first video, the number of moles. This is nothing but a small n. Number of moles in terms of a number, given number by Avogadro number. This n is a given number. In terms of a mass, given weight by molar mass. W is in, this also is in gram, given weight, and molar mass also is in gram. And this is in number. And in terms of a volume, given volume, liter. If it is given in ml, then only you have to divide it by 22,400 ml. And given volume also in ml you have to take. And then 22.4 liters. This is the idea. So now all represent now number of moles. Then interrelations can be done very easily. Suppose you look at, if they are giving number of moles, then number of moles multiplied by Avogadro number, you will get a given number. Same way, number of moles multiplied by molar mass, you will get amount of the substance in gram. Then number of moles into 22.4 liter, you will get the volume of the gases. For that, that is nothing but your Y map discussion. Suppose they are telling 2 mole of oxygen gas, O2 gas. Then what is the amount of O2 gas is present? That means they are number of moles into molar mass, you will get amount of the substance. So then immediately amount of O2 will be equals to number of moles, which is 2, into molar mass. Each oxygen atom is 16, 2 oxygen atom means 32. So then one oxygen molecule will be 32 AMU. That means molar mass will be same value, but it will be in what? Gram. So that's why 32 gram. So that's why molar mass of O2, which is nothing but a 32 grams. So then immediately amount of O2 will be equals to 2 into number of moles into molar mass. You look at, they are in relation with a cross multiplication. That's why 2 into molar mass, which is nothing but a 2 into 32, which is nothing but a 64 grams. As or no? Same way, if they are giving you 64 gram of O2, they are asking what is the number of moles of O2, then we used to do number of moles of oxygen will be equals to given mass, given weight, which is 64 gram, divided by molar mass, 32, which is used to come how much? 2 moles. So that means whatever mass is given, if you want to find out the number of moles, simply divided by molar mass. If they are giving the number of moles multiplied by molar mass, you will get the amount of the substance in gram. Same way, if they are giving in a given number divided by Avogadro number, number of moles. Number of moles into Avogadro number, you will get a given number. Same way, number of moles into 22.4 liter is your given volume. Given volume divided by 22.4 liter is a number of moles. Based on that, now I will give you a solid foundations, that mantra, then your calculations of mole never be mistakes. So then you look at that mantra. Now that is called as a Y map. I am giving you this Y map idea. Now here I am giving you in the middle, this is nothing but a number of moles. Number of moles. And this is represented by small n. Then if you want to go, suppose here I am giving given number. Given number. Now, given number 2, you want to come to the number of moles, you have to just divide it by Avogadro number. Then number of moles to the given number, if you want to go, multiplied by what you have to do? By Avogadro number. You look at, that's what operations we did. So, given number divided by Avogadro number, number of moles. number of moles to I want to go given number multiplied by Avogadro number. You will get that given number. Same way you look at. Here they are giving, if you look at that things. Sorry. Okay, let us. Now you look at. So, now you look at here. Y map we are going to discuss. Here they are giving given number, and given number to number of moles means divided by Avogadro number. Number of moles to given number multiplied by Avogadro number. Now here what we are going to discuss, you look at. Number of moles is there, then number of moles to, here I want to come to given mass or given weight, whatever you call it, given weight or given mass, same thing. So number of moles multiplied by molar mass will give you given weight. Given weight divided by molar mass, you will get a what? Number of moles. That's what we discussed. Same way in terms of a volume you look at. In terms of a volume, what we will do? So that means given weight divided by molar mass, you will get a number of moles. Number of moles, if you know the values, multiplied with molar mass, you will get a given weight. Same way, number of moles is there. So then multiplied by 22.4 liters, you will get a given volume in liter. You will get a given volume in liter. Given volume, and that you will get in liters. And then given volume is there in liter divided by 22.4 liters, which will take you to the number of moles. This is nothing but your Y map. If you understood these operations, whenever they are giving the problem, whatever way they are giving, then easily you can solve the problem within the time. I hope you understood all the concept very clearly, and to get the more videos, you please subscribe our channel. My channel name is Kunal Sir at JEE NEET Chemistry World, and your active participations, liking, subscribing and put the bell button only will help us to do more and more videos, and I am expecting very much constructive comment on the video so that together we can make a difference world. Thank you all. Thank you very much.